this thing. Object-oriented programming, which is the point of this whole unit. We're doing Android as the tool we use, or Java as the tool we use to explore object-oriented programming. But object-oriented programming is a conceptual thing that a lot of languages sign up for or designed around. And yeah, it's a whole way of thinking about programming rather than just a sequential get some input, process, and output it. It's a whole sort of re-look at how you do programming. And we sort of looked at it. We looked at it a bit last week, I think, didn't we? We started looking at, or did I just dream that? I have dreams about programming, which is really weird. And so I wake up in the morning, I feel like I've done a whole day's work because I've been programming all in my dream. So anyway, also, yeah, this joke will be hilarious to you at some point in the near future. Hilarious to you.
Like now?
Well, maybe for you. But yeah, what is the object-oriented way to become wealthy? Inheritance. Ha ha ha. Anyway, I occasionally just Google, for these presentations, I Google occasional phrases just to try and find good pictures to put in to make it. And I put in programming joke, and this was like the best one that came out.
It's not bad.
It's not bad, but it's not good. But, you know, anyway, I don't know who made it up.
Have you ever heard of this binary joke? There are 10 kinds of people in this world. Those who understand binary and those who don't.
Yes, except it doesn't really work if you say it out loud. It's only a written joke. But yes, I have heard that one. All right, object-oriented programming. Sequential programming, which is what you've done before. You've done Pascal, you've done Robot C, and you've done it... well, Pascal is sequential programming anyway. Robot C does have... Maybe? I don't know. Robot C might have the ability to do objects. I haven't actually tried. But sequential programming... Sequential programming is basically start out saying, please enter a number between 1 and 5, collect the number, and, you know, simple case switch statement. And some of the things you want to learn about is, yeah, data types, variables, loops, decisions, all that sort of stuff still fits into object-oriented programming. Nothing has changed. We're not deleting things from your knowledge. We're adding to it, okay? So nothing changes. You can program in Java completely sequentially with no object-oriented programming whatsoever, which is fine. So, but yeah, but it does have its power. So, let's recap. Data types. They've got standard ones like integer, strings, floats, or doubles, and arrays. Now, we're going to go through arrays again in more detail, because arrays you can get really powerful, particularly when you start dealing with objects. But yeah, so these are, or at least integers and floats, what's called primitive data types. They're basic things. Integer can hold a number, and that's it. A float can hold a decimal point value, and that's it. And a double's pretty much the same. There's a fine difference between the two. Strings, they're not a primitive data type in Java anyway, because they're made up of, they're basically an array of characters. And a lot of programming languages do this. A string is just it's hidden in the background, but it's just a string of characters. And so a character, a char, is a primitive type. And a string is just an array of those. But they hide it under this thing called a string. I think in Pascal it's just a string and that's it. But in Java and sort of more complex languages, it's an array of characters. So anyway, so that's just sort of quickly, again, nothing's changed. We're not removing anything like that, we're just adding on to it. But object-oriented is the sort of next step. XKCD, I'll let you read that one. I forget which one this is. Oh yeah. I like XKCD, it's amazing.
Did you read Control Delete at all?
Sorry?
Control Delete.
I did for a very long time, and about a year ago I just stopped.
Stopped?
Yeah.
Because the person that killed off, like, Ethan, Lucas and stuff,
He killed him off.
Yeah.
They're the main characters.
Yeah, I know, like, all he's been doing is just, like, little stuff. He did Console Wars, which he...
Oh, okay.
He's been doing
that's
pieces, and then just, like, he does a lot of the 4-player ones now. But he killed them off and he just hasn't restarted it.
Oh, that's a shame, because, I mean, there's only so far you can go with... This is an online comic, if you didn't know, Control or Delete. But, I mean, there's only so far you can go with the main character who's just insane. because you can only get so many crazy situations. But anyway, yeah. So I just whatever I'm redditing at the time, I put it in there. All right, object-oriented programming. It's an extension of sequential programming. Objects are data types on steroids. Okay, so a data type like an integer or a string. An object is just an extension of that. Okay, so you can create a object in memory and use it like a variable. So just think of them as complex variables. Rather than storing an integer, you can store a lot of things, and you can actually run commands on these objects. We'll talk about that in a minute. So they're at the basic level, they're just data types, the standard data types you already know, but more complex versions. So they're variables that you can have values and methods associated with them. Now, methods are just functions or procedures or anything like that. So you can actually run a command on a variable and say add 1 to you, or what's this current state, things like that. So yeah. All right. So yeah, some new terms you've got to be aware of: functions or procedures, subroutines, subprograms, whatever you'd use for that. They're now called methods. Okay, from now on I'm going to be referring to them as methods, because that's what they're called in object-oriented programming, methods. And variables are called attributes. There's also some other terms which are related to methods and attributes, which I didn't put on this slide. There's for methods, they can also be referred to as behaviors, because it's the behavior of the object that you're using. Attributes can also be referred to as the state, because it's the current state of the object, what the values are. So that's some other terms: state and behavior. We'll look at that in a bit more detail later as well. All right. So objects and classes, they're custom data types. You can write your own data type. If integer doesn't do what you want it to do, you can write a new one. You can make it as complex as you want. So you can create, the example here, you can create a frog in memory. So you can have it's like a collection of attributes and a collection of methods around a frog. So you can set its age, its how many eyes it has, what colour skin it is, how many feet have French people taken them and eaten them for the legs. All these things, you can have all these variables all associated with a frog, and it's all contained in the one thing. You can also have methods like croak or hop or avoid getting eaten by a French restaurant, that sort of thing. So you can have all these methods associated with one thing, and it's all called a frog. And hidden behind it is all this complex information. Much like a string hides the fact that it's an array of characters. So yeah, it's just there's a term for it, and I can never pronounce it properly, so I'm going to say it really slowly. No, okay, I'm not going to try it because it's embarrassing. It's obsuf.
Oh God.
Yeah. I can never say it properly. It's one of these things. It's a mental blank in my brain, and I can never say it properly.
I've had to pronounce it for a little bit.
Yeah, it's weird.
It's pronounced really weird.
Yeah. Anyway, it's a term for hiding things. I'll find the spelling of it, and we'll try and pronounce it together. This is a bit that I might edit out of the video where I embarrass myself by saying not being able to say a word that relates to object-oriented programming. It's a term that it's do you know it? It's obfuscate or something like that. It's hiding information behind something. It's sort of yeah. It's like yeah. This is a bit I'm going to cut out. Yeah. So edit. All right. So you can make a frog, and you can associate the values and the methods around that. There you go. How do you pronounce it?
Obfuscate.
No, that's not how you pronounce it. No. It's obfuscate. Obfuscate. Yeah, see, I can't, even though I'm looking at the word, I can't. Obfuscate. Obfuscate. Blah. And I'm going to forget it tomorrow. I'm going to forget it when I can't see it. It's a word to hide something behind something else. So a string, it hides the implementation of it because it's an array of characters by just calling it a string. So that's what that is. All right, let's move on from that word.
Obfuscation.
There you go. Obfuscate. See, I can't even say it now. Anyway, It's one of these weird English words that's really, once you get it, it's right. Thank you. All right. So, objects, real life objects in, outside programming, they all have a state. They have a current state of being. And this is what we're trying to emulate in our programming, in object-oriented programming. We're trying to emulate real life objects and conceptual objects as well. But let's think about real life objects. So, a watch has a current time, is an example. So, the time would be a variable or an attribute that you store about a watch. A pen is the amount of ink, so maybe a percentage value of how much ink it's got. And a car has a current speed. Now, all these attributes can change. Like, the speed would be changing, thousands of times per second, because it has to be incremental and changes. It wouldn't be exactly the same the whole time. But there's a current state which can change at any point. Sometimes they could be constants. They could be constant, but they could change as well. So it's the same sort of thing, but they're all states. And the states can be updated as the program allows, so the speed of the car would change all the time. The pen's, like the amount of ink in the pen, would change, hopefully, only when it's being used. So if the pen is in a state where it's not being used, if you had a Boolean to say being used, yes or no, or true or false, if it's false, you wouldn't be able to reduce the amount of ink. That sort of thing. So you can check the current state, and the watch would constantly be updating, and you have to time it so it's updating at only a certain frequency, which is every second. So yeah. And so the state is the variables. Or you could also argue that the state is like you're looking at all the variables or all the attributes, and that's the state at once, not a particular variable or attribute, sorry. I'm going to get into the habit of saying it myself. The attribute, it's the collection of attributes is the state. And the behaviours is what those objects can do. Like they can spin around on chairs, they can touch each other, they can touch each other's chairs. This is a bit I'm not going to edit out of the recording because I want people to know that while I'm talking, people are spinning around on chairs and touching each other. Not inappropriately, but they're touching each other. Do you want me to name names? And I'll put it up on YouTube.
Yeah.
No, I didn't think so. All right, remember, I am in charge of what I say and what I do and what I edit out. So if you want to have your name associated with something stupid behaviour, I can put it up on YouTube for everyone to hear.
So there's going to be a really random obfuscate.
There you go.
Okay.
That's not how you use it. But anyway, I appreciate the effort.
No, I mean, just randomly in the YouTube video, it's just going to say obfuscate really loudly.
Yes, I wanted to say, I've learned how to say this word. All right. So objects also have behaviours. They're the methods. So yeah, the watch has the ability to change the time. So it has a method which says update time, or you can either change it regularly, like every second it updates, or watches have the ability to reset a time. So you want to be able to overwrite the current time and set your own time. So that would be a couple of different methods maybe. The pen can be used to write, so you set some values and things like that, and a car can be driven. So they're methods that run on the objects, and they're actually inside the object as well. We'll look at some examples, some more detailed examples in a minute, so it's a bit more obvious when it's written down. But I just want to get some of the terms out of the way. And behaviours, yeah, this is the key point. Behaviours change the state of the object. So the methods would change the variables inside the object. The variables or the attributes can't change the methods. That's bad. Yeah, anyway. And objects, not just physical objects. Okay, these can be bank accounts. So it's a conceptual thing as well. Initially, we're sort of going to be looking at physical things because it's easier to visualize or conceptualize in your brain. But eventually, yeah, you can do it on these non-physical objects. So yeah, the examples there, the state would be the available balance. Hopefully that's above zero. Although it is the day before payday for me, so I don't want to look at my bank account because it might be below zero. But and the behaviours would be deposit and withdrawal. So when you deposit money, your available balance would go up, hopefully. When you draw, it goes down. So that's the sort of how it would affect different things. All right. Next thing is key words in object-oriented programming. Two fundamental concepts in object-oriented programming: classes and objects. Okay, the two words. If you well, I'm not going to say if you learn nothing else, but you need to understand what classes and objects are. If you're confused in the next week still about what classes and objects are, first of all, come talk to me, but otherwise look up on the web, the interwebs, about classes and objects for object-oriented programming, because there's thousands of websites out there that explain it. There's videos, there's lots of things to explain what this stuff is, because these are the two fundamental concepts in object-oriented programming. Yeah, so what you do as a programmer, you define the class, which is like the blueprint of an object. You define the class, and then you create an object based on that class. So like with an integer, if you sort of equate an integer as a class, you create a counter which is of type int. Okay, so you're creating an object, a primitive object, based on a class which is an integer. So you might create a class called frog, and you create Freddy the frog, and then you start referring to Freddy because he's a type of frog, but the behaviour and the state would belong to Freddy, not frog, because not all frogs are the same. And so Freddy, we'll look at that a bit more detail. I'm just trying to explain classes, objects, two fundamental things. Classes is a template, the basis, the blueprint of objects. All right, so let's look at a dog now. Dog, the state would be like the date of birth, number of legs, and the name. So they're variables, attributes, where you store the data. And the behavior is, again, a dog does a lot more than this. I'm just cutting it down to make it fit on not only the slide, but so we're not listening to the whole thing. But they bark, they run, they sleep. They might also chase things and stuff like that. But anyway, bark, run, and sleep. They're the methods. So that's the behavior. The state is the date of birth. Why are you laughing?
Because you missed a really good opportunity here to cover this slide with dogs.
Oh man, no, yeah, that's right, yeah. Anyway, yes. Is it pronounced Doge? We talked about this the other day, didn't we? Doge or Doge?
There's a company called Doge Tech.
Doge Tech.
Yes.
Was this created based on the meme, or?
Yes.
Oh, that's even
And they
worse.
made their own version of Flappy Bird. Did you see people selling their phones on eBay with Flappy Bird on them?
Yeah, someone sold it for like $2,000. One of their Android phones with the Flappy Birds. The game's, I haven't played it, but the game doesn't look that good. Anyway, dogs. UML is another thing we're going to have to get used to. It's unified modeling language, let's say. I think that's it. Unified modeling language. Yes, Liam.
Why would the date of birth be string?
It's a string.
Because a date of birth doesn't exist in Java. You could create an object called date of birth.
Would you like make it in numbers or something like 1910?
Yeah. Yeah, you could do that. You could do multiple different ways. I just tried to keep it simple. But yeah, in real life, you wouldn't make the date of birth a string. I agree. But in this case, I just wanted to put it up there. This is UML. Do I have a mouse? No. So you put the class name up the top in the first box. The middle box is all the variables, attributes, and the data type is next to them. The data types could be other objects as well, or other classes, and the behavior is the methods. The void on the right-hand side after the colon, that is the return type. So for the methods. So, yeah. All right, so this is the equivalent class in Java. So we'll start programming, as I said, once Eclipse actually works. But the class is dog, which is the name, and then the state are these variables up the top. Attributes, and then the methods down below are the behaviors. So that's how the Java class matches the UML. And next to dog, you do see class. So everything in Java is based around these things called classes, and that's the basis. So now we've created a dog class. We can create a Roger or something like that. I think I use that. Couple other key terms: instances, instance or instantiation. Some words that I'll be saying over the semester. When you create an object out of a class, you create an instance of that class. Okay, so these are some keywords: instance, because you can have multiple instances of an object. all with different state, all with, well, the behavior is going to be the same, but they all have different states. And so that they're referred to as instances. Yeah, classes are defined in code first. So you create a dog class, and then you create objects from that class. So here's just an example of instance. So I can have the one dog class, and I can create a Spot, I can create a Rover, and I can create a Jeff, because I couldn't think of another standard dog name.
Bolt.
Sorry?
Bolt.
Bolt. Oh, from the movie. Anyway, so Jeff. Yeah, it's good enough. So this is the code. Once we've created our dog class, which we saw in the previous slide, this is a code to instantiate an object, or to create an instance of. So here we've got dog, new dog. If you ignore the rest for the moment, you ignore the rest. Dog, new dog is exactly the same format as if you're creating an integer or a string or anything else, because this is the data type. Okay, this first dog is saying I'm going to create an object or a variable, an attribute of type dog. Okay, so you could say int counter, and that's exactly the same format. So just think about that. I'm saying I'm creating the data type here because dog is a class, but it's also just a data type. It's just a complex data type. So dog, new dog. Now this bit here, we're going to go into more detail about that later, but basically Java, you need to say, okay, I've created this, I've created the memory space for a dog. Now I need to fill that space with data, and that's this new dog bit. So you have to fill that data. You create the empty space, you need to fill it with something, and that's that. And that just creates an empty dog called new dog. And then you can just say new dog.name equals Spot. So I'm setting the value, setting the attribute to be Spot as a string. So here's that. The class type is dog. The instance name is new dog. And then the attribute, or the part of the state, is the name. So that's how that works. Another example here, going back to the example I think we looked at earlier, or a similar one. This just says it's a complex hello world. Hello world, what is your name? Scanner user input equals new scanner system in. So this third line here, this is actually creating an object in memory of type scanner. Now I don't know what type scanner is. I don't care. I don't need to know the details at the moment about what that object is. I just need to create an object called user input, which is great, and I fill it with an object, new scanner, and inside brackets, system in. Now again, I don't know what that is. I don't care, well I do care, but I don't need to know the details of it. It's obfuscated, hey, I got it right there, obfuscated behind this scanner object and this system class. This is actually a class here, this system, and I can tell you how to identify that sort of stuff later. But it's obfuscated. That's 3 times in a row. It's like, no. And then now with using that user input object, in this next line, I've got the string username, exactly the same, remember, exactly the same format. Data type first, and then the object name. And here I've got user input.next, and so that's using that instance of this scanner class. So, and then I can use that later. I can use user input whenever I want. Okay, so that's how the system works in Java, and other languages do similar things. But yeah, that's how that works. So that the classes are scanner. Scanner is a class. User input is an object of type scanner. So these are just some terms around about object-oriented programming. User input is a type scanner, and the system is a class as well. But anyway, so that's sort of how Java works, and this is hidden for you when you first start Java about how to do this stuff. So yeah.
I'd say it's obfuscated.
Obfuscated. There we go. I'm going to have to keep saying that word a lot. You're pointing at my code. I've got to point out, someone in year 11 criticised my code, my Java code, and I took great offence. But he was right. So, yeah.
It's just that there's a space between.
Sorry, which one?
Would you like to play a game?
There's a space there, so
Yeah.
his name's right next to it.
Yeah, it's supposed to be. There's supposed to be a space there because you're right. When this outputs to the console, it would actually, if I didn't have that space there, it'd say comma and the username would start the next character, which is not right. Well, it's not right English. It's not correct English.
Didn't know it makes
If I could
all
speak
right.
properly. So yeah, the space usually. That's why the space is there. Okay. Very quickly, classes are blueprints or templates for the objects. So your dog class, you can create lots and lots of dogs, but the dog is a blueprint. So if you also think about it, the other example is toasters, for argument's sake. You buy a toaster. That's very exciting. Everyone loves toasting. But yeah, and like you go to Good Guys and you buy your Acme brand toaster, but on the shelf there's 15 Acme branded toasters. They're all exactly the same model. They're not handcrafted lovingly by people in a warehouse somewhere. Someone has created blueprints of a toaster for that particular model, and then they feed it into a computer, press a button, and 50,000 toasters come out. It's not usually that quick. It might be a bit more complex than that, I'm guessing. But they press a button and toasters appear. But so if you think about that, if you think about sort of manufacturing, the blueprint is your class, and the actual physical things on the shelf, they're your objects. They're all based on the same original blueprint, and they can all do the same thing. But the toasters at any one time can be either toasting or not toasting. They can have a toasting level. What's the heat level or whatever it is? How charcoalish you want your toast. So they all have those settings that state the behaviour of toasting, but they all got the same they got the same state, but they've all got the same behaviour, which is you push it down, you wait for the toast, you can press cancel if you want to, or you got crumpet mode or whatever other mode you got on fancy ass toasters. I don't know. So that's a sort of, if try and think about classes and objects like that. Classes are your blueprint. Objects are the things you create out of that blueprint. Okay, so that kind of makes sense. It's a really hard concept to grasp initially, and you will struggle a bit, and that's fine. We'll get over that, but it's because this part of programming is all conceptual. So yes.
If you don't want to go over it, that's cool. But it says when the second line changes objects to affect classes, and then down the bottom you said usually, if it's possible.
Yeah.
What do you mean?
Most of the time, if you change, like, let's say Roger the dog, you got Roger, you got Spot, and you got, what was the other one? Jeff. You got these three dogs, exactly the same type of dog. They're created from the same class. Let's say Roger runs out on the road and gets hit by a car and loses 2 legs. Oh, tragic. But if you affect that state to say Roger now has only 2 legs instead of 4, that doesn't affect the other dogs, or it doesn't affect the original blueprint of the class, but it affects that current state. But in object-oriented programming, you can set something so that when you change something in one dog,
So
it
say
affects
like
all of them.
If you had I don't know, for some reason like 2 squares, and something happened to one of the squares.
Yeah.
You could possibly go to say if that happens to one, then either that happens or something else happens to the other.
Yeah. So let's say I'm just trying to think of a good example. Let's say a clock. You've got a single clock, which is fine. You can set the time. But let's say you've got a building like this, and you want to have a centralized clock system. And so you've got individual clocks around the room, but you don't. If daylight saving comes around, you don't want to set the time on every single clock. So you'd have a central system. You can change the time of one clock, one instance of a clock, and you could actually program it so it would update all of them at once. So but you'd go out of your way to do that. So you'd want to program that in specifically to do that. But that's a good question because, yeah, I did put that there. Initially, we're not going to make objects interact with each other, but it is possible to do it. But, yeah, it's not. I mean, objects can definitely interact with each other. Sorry, I should clarify that. They can definitely interact with each other because they have to. But, yeah, changing the state on one instance of an object doesn't necessarily change all of them, but you can set it that way. All right. So yeah, change the number of legs on Spot doesn't change legs on River. All right. So here's a quick class example. We've got dogs. We're creating dog 1 and dog 2 called Spot and I didn't change Spot. The other dog 2. So Java runs this line. Okay, we're going to create a new dog. It's called dog 1, and we're going to fill it with an empty dog, empty shell of a dog. Oh, isn't that depressing? An empty shell of a dog. Then Java's going to run the second line, which is creating a second dog, dog 2, and the two instances of the original class dog. And I'm going to set. By the way, this animation took like entire afternoon to get organised. It's going to blow your mind in a second. Trust me. Just pay attention. The animation is going to go to the next level. It's pretty cool. So Java then runs dog1.name equals Spot. So I'm setting the attribute of dog1 to be, or setting the name attribute to be Spot. Are you ready? A second arrow appears. It's very exciting. Again, all afternoon. I've got very little to
You can
do.
do that in Flash. It doesn't take oh wait, you're on a Mac.
Yeah, Flash works on Macs.
What?
Yeah.
Yeah.
Well,
Or is it just iPhones?
yeah. But why do you want it? The Flash is,
Dead.
yeah. Anyway, so now we're going to output to the console, which is the bottom part of it. Dog's1name is dog1.name. So you can actually refer to the attribute by setting it and retrieving the information. And that's quite a complex area that we're going to get into later, but you can actually do that. So it's going to output Spot. Dog's1name is Spot. And so what I'm trying to show here is when you run dog2.name, because we've only set dog1.name, it doesn't change the other dog. The dog's it doesn't change the name attribute on dog2. Okay, so that's what this example is supposed to be. So quick summary. Classes are blueprints. Objects are instantiated from classes. These are some keywords as well. Classes, objects, instances, instantiation, obfuscation. That's another keyword. Thank you. And yeah, objects don't interfere with each other unless you tell them that they will interfere with each other. All right, so here's a quick task I want you to do while I try and fix up Eclipse as well. Is I want you to design UML. You can do it in Word. I don't really care. You can do it in Excel. Just sort of a simple table, 3 boxes. And I want you to write the Java code. Design the UML. Don't worry about Java right now. We'll fix that up once we get Eclipse working. Design the UML for the 4 objects. 4 classes. And yeah, concentrate on the attributes and the behaviors of those animals, particularly the Wookiee. Yes, whatever you want to call that. So, do it in Word, do it in Excel, I don't really care. Just have a quick, simple table. You can do it in pairs. Pairs might be good so you can have a talk about it. But,
Can we do it in trios?
sorry?
Can we do it in like trios?
Yeah, that's fine if you want to do it in threes, that's fine. I just don't want one answer. I want different discussions. So, have a think about that. Start writing some ideas down, making sure you break it up. I'll put the example back up of the UML so you can see what it's supposed to look like again. Okay, can we wait till it stops recording so you're not going to offend the entire universe of people? A Wookiee joke, okay.
So,
Is this going to offend me as a Star Wars fan?
Probably.
Yes.
I had a Wookiee steak the other day.
It was a bit chewy?
A bit chewy.
Yeah. I've heard that one, yeah. All right, cool. So start doing that. I'll put so you've got a dog, a cat, a frog, and a Wookiee. And I'll put the example back
Can
up.
it be young cats?
Sure.
If you want to die.
So, thank you very much.